All right.
Wonderful.
Great. All right then. Hi everyone. My name is Miriam Cristofoletti. I am a final year robotic engineer student at the University of the West of England. And today I'm gonna tell you a bit about my journey into engineering and why I love it. So I'm gonna start with a bit of a background. As you can guess from my surname, I come from Italy, where I was born and raised in a little city near the Garda Lake. It was great because almost every weekend my parents used to take us to the lake to have a nice family time. I spent there most of my life, and then roughly 5 years ago I moved to the UK, first to Exeter and then to Bristol, two fantastic places where I always feel like I'm at home, really. And this is me. In all these pictures, I was about between 6 and 9 years old. I was a very active girl, a lot into sports in particular. I used to do gymnastics, rollerblading, swimming, at a competitive level, really. Also at home, I used to always be up to something, busy crafting and building things with carton board.
So we can actually hear what she's saying.
Sorry? What? Sorry? Oh. Okay, I'll carry on. So basically, I was saying I was always up to something. Even though I was good with numbers and science in general at school, I don't remember myself thinking of becoming an engineer. But I do remember wanting, like, I've always wanted to invent something, create something. I wanted to be an inventor, really. With the years, though, I learned that people don't always agree with you and with your decisions. They don't always support you. I'm thankful because my family and my parents especially were always supporting me with everything, every step in my life. But people around me tried a bit to stop me saying things, trying to break my dreams. And here comes one of my favorite movie quotes. From the Pursuit of Happiness, Will Smith says, "Don't ever let someone tell you that you can't do something. You got a dream, you got to protect it. When people can't do something themselves, they're going to tell you that you cannot do it." And this is so true. In fact, when I started to grow up and I had to choose my secondary school, I wanted to go to a scientific and technological school, high school. But I clearly remember people telling me things like, "You're a girl, that's a boys' school, you can't do it." And my maths teacher in particular, I remember her laughing at me because once I made a mistake in a calculation and she went like, "Ha, you can't even do multiplications." And that really hurt me. I got hurt in my soul for the first time. But I stood up thinking, I don't care about what others says. I don't care, really. So I applied to that very school. And yes, I found that there were, like, I was in a class with 20 guys and only 4 girls. Plus, I was the only Muslim girl in the entire school. But I loved it. I had such a great time with my classmates. I built my fundamentals in science and technology. And at the end, I graduated with the first. Then some nasty comments and skepticism came across from other people again when I wanted to apply for an engineering university, and then and also when I wanted to move abroad. So they went like things like, "Why going that far? You won't make it. You girls don't do that. You won't like it. That's a man things," and things like that. Anyway, I couldn't care less. And I wanted something, and I pursued my dreams. So I studied materials and nanotechnology in Italy. And then once I moved to the UK, after working a little bit and learning English, I started robotics engineering at UE. So what does that make me and all the other people studying engineering? An engineering student? Once our head of department highlighted a really powerful point, that engineering students should actually be called student engineers, because the reality is that we are already engineers. You don't need a certificate that says that you have the qualities, the creativity, the ambitions, the problem solving skills of an engineer. You already have curiosity, interest, passion, and then because of that you are driven to engineering, which is, by the way, amazing, and I'm going to show you why. So in my robotics degree at UE, we learned to build and program robots from the very first year. And then all this knowledge is developed over the years. Here there are a few projects I've been working on. And this one, for example, is a robotic arm I programmed to manipulate objects. And this one here is a mobile robot built with Lego parts following a line. And here again, there are some little like short videos about another project for another mobile robot, able to run in a maze and try to solve the maze, really. So you can see things don't work at the first attempt, and that's the whole point. I mean, it takes effort and persistence. After that, between my second and third year, I went, where is it? Yeah, the slides are a bit, okay. So between my second and third year, I had my year in industry and I went to work in a company called Rani Show. I was in the laser calibration department in the electronics team. And I had two main projects to work on throughout the year. They were both test boxes for to assess two different machines. And it was a great experience because I got to see the professional engineering environment, what it is look like, and I developed my practical skills. Because these boards, I designed them, I built them, and I test them, so everything myself. Also, another great experience is being part of the Bristol Robotics laboratory at UE, where I took a summer internship 2 years ago, and then now it's where I'm working on my dissertation project. These are a few past and current projects made by researchers in the BRL. So this one, the first one is here, is a humanoid robot for a human-robot interaction project. This one here is a robot with whiskers. As you can see, it's like to sense the environment. And all these ones are many, many, many tiny little robots able to work together and in a decentralized manner and without a leader. For example, like the same way they ants and bees work, basically. And this one is my favorite. This is Pepper. And it's a humanoid robot used as a companion for elderly people. And it can also dance, as you can see. It's showing off in one of the registrations events at UE. So here is what I do at the moment as part of my research. The aim of my dissertation project is to build a system, like a robotic arm, able to learn through a camera from a human action how to manipulate objects. And for example, these are like little tests. The first one is a program trying to track my hand, like the center of my hand. And then the other one is a program that detects the, if it runs, yes, it detects basically the color and it tracks something with that specific color. Then, where is it? Yes, then here is other two tests. This one is basically tracking, recognizing a basket on a table, and it tells us the distance from the camera as well. And this one is, again, another hand tracker, but this time is tracking the fingers joints, basically. And yeah, I mean, at the moment, I have moved some of the equipment to another part of the lab, and suddenly my program stopped working properly. And well, my supervisor and I think it's probably due to the change of light. And this, for me, means that I have to get back to work and try and fix the issue. And this is what engineering is really all about: creating, testing, building, trying again, fix things, but never, never, ever give up. So where do I get my inspiration? Really, from everywhere. Mostly from sci-fi movies and cartoons. Since I was a child, I've always watched kind of futuristic stories and series. Most recently, Marvel's movies are my favorites, especially Princess Shuri here, which is actually one of the very few female smart characters around. But really, there are also many amazing people, real people out there, not only in fictions. So, for example, the father of SpaceX and many other companies, Elon Musk. For example, I know some people, they criticize him for many different reasons, but what I like is his strength, his determination. And when everything seems over, he's like, he stands up and he's like, whatever, let's start again. And this is incredible. Also, the Google founders, Sergey Brin and Larry Page, the incredible job they've done for one of our like most powerful online tools we have at the moment. And also Steve Jobs, who really created the era where we are now. And I can add Bill Gates with Microsoft, Jeff Bezos with Amazon, and many, many more businessmen who really started from a garage and built all the way up. But then I think what we don't really think of, what we don't really know, is all the other people hidden from the light and the cameras who did an amazing job. But like that, there was the fundamental for all these guys to do. And they did it way before these guys. So, for example, Mary Jackson's, NASA's first Black female engineer, Katherine Johnson, NASA's mathematician, who calculated many trajectories of many missions, American missions in the space. And again, Dorothy Vaughan is also NASA's mathematicians and one of like the first Black supervisor at NASA. I mean, if these women and other women like them didn't do what they did, Elon wouldn't be able to send his rockets to space. I mean, that's incredible. And another example is Karen Stark-Jones, a computer scientist who built the foundations of search engines. If she didn't do what she did, today we couldn't be able to say, like, to use the expressions, Google it. I mean, that's also incredible. And again, Ada Lovelace, famous for her work on the very, very first computer in history, if she didn't do what she did, I mean, all these guys couldn't be able to do anything, and the world today would be very, very different place. This is all impressive for me. I mean, it's incredible, but it does take hard work. Everyone sees the success of these great people just looking at what they achieved. But the reality is that there is much more behind the scenes. What we don't see is all the persistence and dedication these great people had, and many failures and sacrifices these people had to go through, and disappointment, discipline, hard work. They actually started from nothing but an idea, spent a lot of time trying, and then the rewards for their hard work came. And believe me, guys, it always comes. It always comes because you put a lot of effort. And when you have a great idea and you want to change the world, don't wait until you find the perfect role model to follow. You can be your own role model. Take inspiration from here and there from other people, that's fine. But then be the first. Be the first. If I was to wait for a person in the world or in the history matching my aspirations, my identity, my background and stuff, I would be still there looking for it. I mean, it has to be a woman, it has to be Muslim, Italian, engineer, strong personality, many things all together that what I want. So I have simply always thought about myself, who do I want to see in the mirror in 5, 10 years time? And this could be you as well. Whatever is your passion, your interest, just never ever give up. Be the first one. If something goes wrong, know that it's just the first step of the ladder. It's just one of the things that happen to you below the water level in the iceberg. One day you're gonna change the world, and I'm gonna hear your story, and you're gonna tell all your failures and sacrifices, but also your successes and your achievements, and that would be amazing, I'm sure. At UE, we have something called Women in Science and Engineering, which is a society some friends and I formed a couple of years ago to promote and support STEM subjects. We do trips, conferences, talks, and other great activities with the support of our engineering department. And this year, we have an exciting project in our hands. It's a car-graded backlight designed by Philippa Griffith, winner of last year's Leaders Award competition. Here's part of the team working with me. And we got inspired literally by Philippa's design, and we're going to build a prototype which will be exhibited hopefully at the final celebration event next June in Bristol. So just to wrap it up, my message to you today, to every one of you, is follow your passion, work hard, enjoy your time, and never, ever, ever give up. Take part in this competition and come up with a great idea. Change the world, because next year it could be your design that's going to inspire some engineers like us to build it. And thank you. Do you have any questions?
Wow, thanks, Miriam. That was brilliant. Thank you very much. There's actually already a question there for you. It's just come up. Could I ask you to come out of your PowerPoint and show your full screen on the screen, please?
Yep. Just 1 second.
Okay.
There's yeah.
There we go. Excellent.
Yep.
And can you see the question? It's from Wardle Valley.
Yeah. Just.
Which country is pioneering the development of robots at the moment?
All right. So which country is pioneering the development of robots? So at the moment, there are actually many countries developing robots. What I can think of is, America, Japan, the UK as well, some countries in Europe. It's, many places. I can't really say just one country. Many questions. So, have you ever made a flying robot? No, a flying robot, I haven't done it yet. No. But it's actually in my wish list, actually, really. So what materials do you use to make your robots? We use many materials, mainly plastic, and sometimes metals. It depends what we need to build and what are the requirements for the project. If it has to be light, if it has to go underwater, if it has to fly, for example. It depends on the requirements, really. What was your first idea for a project? I guess it's for the Leaders Award. What was your first idea for a project? So we thought we selected a few projects from the winners from last year, and we selected the most feasible in terms of time, in terms of resources. Another one was quite an interesting one, was a laundry rack for people in a wheelchair. So the laundry was going up and down, and the person on a wheelchair could like hang the clothes, and then the laundry rack would lift up. And so it was quite interesting idea, actually. How do you make the robots? So it's not something immediate. It takes a while, and it takes usually the effort of many people working together. So it's a really group work. How do we make it? So we start with the design and what we want to do, what is the task that we want the robot to do, and then you start looking for the resources, which materials we will need, which motors, which actuators, and things like that. And then we start building, and then also there is the coding part as well. Where is it? What was your first design? The first ever robot I built was one of the robots I showed you before. It was with the line, the line following robot with Lego parts, and it was great. What other notable engineers have you met? Ooh. So the people that I mentioned, I've never met them, to be honest, but are people that I really look up to for like many things they've done. Notable engineers have you? I believe good engineers are all around us, really. In our university, I find inspiring many of my lecturers, many of the staff members, many of the researchers, many people I met in industry as well in my year, in my placement year. So yeah, it's great. What materials do you use to build your robots? I think I already talked about this one. Oops, why is mine? Sorry. What do you enjoy most about your job? Oh, the best thing of my job is when I start seeing the first results. So basically, if I'm programming the robotic arm doing something, the first movement for me are the best moment when I see it doing what I want it to do. And sometimes it doesn't work. Sometimes I'm like, oh, why it doesn't do that? But it doesn't matter. It's part of the process. Who inspired you to be an engineer? What materials do you use? So materials, I've already talked about this one. Who inspired you to be an engineer? Well, I already mentioned many people, and it was mainly my passion and my curiosity, really.
Again, after you were go and stand outside.
Sorry. Oop. Okay.
Yeah, I think we've got an unmute somewhere. You carry on. Sorry, Miriam.
No, that's all right. Why did you come to the UK to study engineering? Oh, right. I moved to the UK because I wanted a change, really. Some people they just want to move abroad because they've been living in the same place for many years, and they want to try a new experience and see new people and see new cultures as well. So I was always like attracted by the UK since I was little, and I said, why not? Let's try it. What is your favorite robot that you have made? I think it was the one running in the maze. That was a tough one, and that's my favorite, really, because it was a project that took us, like, it was a group project, first of all, and it was the duration was throughout the whole year. So it was really good experience, especially because it helped us to develop teamwork. You have to be patient with your team members. You have to understand the differences and the different opinions and get to work together, which is not always easy, but at the end you are working on the same goal and on the same project, and you gotta have to get along. And yeah, and that was my favorite robot. It was my favorite robot also because when we were programming it, like, to avoid the walls and stay on track and going straight, it was like it had its own personality. It was going into walls, and it was like, I don't care, I go wherever I want, and things like that. So it was kind of our baby, really. How long does it take to build a robot from start to finish? Right. It depends on the robot. It depends on what you want it to do. And it depends how many of you. If you are alone, it would take quite a while, really. If you are a group, it could take obviously less. As I said, the mobile robot running in a maze took us, well, less than a year, because it's an academic year, so it was basically 8 months, I think, roughly. And yeah, I think roughly like that. What inspired you to go into robotics? I've already said that, but also watched many cartoons and movies, and Baymax in Big Hero 6 is my favorite cartoon. What's the most challenging thing about studying engineering? Okay. I think the most challenging thing is to keep on going, really. It's when you see things don't work the way you want, or when you see things getting a little bit harder. Especially, I found this myself between the first and the second year. It was obviously harder, and it was requiring more effort and more time on practicals and study. But it was mainly the challenge was to don't give up and keep on going. And even if you don't understand something, you go and ask. This one also, it was a very kind of challenging thing, thinking that, like the fear of asking. So I don't want to ask, because then I will look like I don't know, or I will look like less smart than the others, or less capable than the others, or things like that. It doesn't matter. You just go, ask, and you get back with your answer, which is the best, really, because that's what you need. What has been the hardest part of your design? I think the hardest part in the design of a robot is the debug. So when you start building, whether it's in the hardware side of the project or the software side of the project, really, it's you started building, let's say it's in your hardware part of the project, you start building something and you are sure about all the pieces and bits and things like that. And then when you first test it, it doesn't even turn on. Or worse, sometimes you can start seeing smoke, and that's the worst actually. So then you have to go back like step by step and piece by piece and testing every connection that it works, and like basically to try where to find where the error is. Same thing in software. So you have programmed everything, all your functions and everything, and then you run it and it crashes. So you literally have to start debugging and starting looking from the beginning. So what does this work? Okay, let's go through the next one. Does this work? Okay, let's go through the next, until you really reach the point where you find your bug, and then that's it. Why did you want to make robots? I want to make robots because they are great. Robots are friends. It's because they could do a lot for us. They could help our lives a lot. And if you think about like the last 50 years, for example, automation and technology has incredibly improved our lives. I mean, that's a fact. And imagine if this could go even more and even better. It's always like good for us. Some people are scared about robotics and AI in general. They're like, oh, robots will conquer the world or will take the humans' places or whatever. No. Humans are always there and are needed. And robots are like going just to make our life easier, okay? For example, easy thing like the washing machine or the dishwasher. Whoever in the world likes to wash things? Nobody. So these kind of machines and robots in general, they could help our lives and do all the job that it's first dangerous, and also it's like boring for us and we don't really want to do it, and it takes out a lot of time for us to do other things that we enjoy more. That's why I like robots. What inspired you to be a robotic engineer? So I already said that. What is the biggest project you have worked on? The biggest, I think, was is gonna be my dissertation. Yes, that's gonna be the biggest. I think the longest, because it's individual, so I will work alone, and I am working alone, and yeah, I think that's the biggest, and the most interesting one then is gonna be the one that we're gonna start with the Women in Science and Engineering Society for the Leaders Award project from Philippa's design. I'm really looking forward to see how it will come out at the end. What did you want to do when you were younger? Okay, something that I didn't say is that since I was little, I as I said, I wanted to become an inventor, but then like throughout the life I was like keep on changing, and that's not a problem, because as a child you will love. When I was really little, I wanted to become like the ice cream man that sells all the ice creams. That was the best job I wanted to do. And then like growing up, you change and you see what you are best in, and you see the opportunities, and you see your strength, and things like that. And yeah, that's it. how do you program robots? Okay, you basically plug, you need a microprocessor on the robot, or any sort of kind of brain in the robot, that will just make decision based on the sensors and based on any functionality that you want it to do. And then you start coding, and you basically attach it to a computer and you start coding, and that's one way to program a robot. What is the most challenging thing about making robots? I think I said the hardest thing, yeah, is the debug, really. Have you ever given up on a project? I don't think so. I'm that kind of a person that I'm almost always saying yes to everything, and I'm like, yes, let's do it. Like, I don't think I've never given up on a project, I think. Can robots see light? Of course they can. Yes, they can. So either through some sort of sensors or through cameras, they definitely can see light. And sometimes depending on the quantity of light, depending on the distance from the intensity of this light, or things like that, the robot will do certain things and follow certain functionalities that you programmed. Why do you enjoy being an engineer so much? It's because you can actually create things. You can see things happening. And that's what you did. It's like the first ever things that I programmed was like a little board with LEDs coming up and switches and things like that. And I was so excited because whatever I was programming, it was coming up as an LED blinking, and that was great to see, because you are programming something not just for the sake of programming, just on a screen full of lines of code. It's literally, you see an arm moving, a mobile robot running, an LED blinking. It's great. How often do you take projects apart and start again? It depends on the project, but as I said earlier, for example, my dissertation project, it's I've just, like a few weeks ago, I had to move from one area in the lab to another one. And suddenly the program that I've worked on started giving weird readings and results. And it was due to the light, because the light is a very sensitive component of the environment. And so the cameras I was working with couldn't recognize things the same way. Based on the light. And so actually that meant that my project, my coding, was not robust enough to be used, really. Because if you have a camera, and then, as my supervisor pointed out, it's if you have a camera and you just move it slightly, then it doesn't do whatever it was supposed to do, then that's not a good design, that's not a good functionality. So you have to get back and start again. Yeah, but to try not to do this, like not to often do things from the beginning, it's good that whenever you start, you divide your project in little tasks or little components of your project, and then you start testing each one of them individually. And then when you want to start putting them together, you put the first two together and see whether you test it. If it works, if it does, then get the other one attached, and you keep on doing this, and you keep on testing to make sure that you're not like building the whole thing and then test it and it goes crazy, and then you're like, oh no, I have to start from the beginning. So yeah, this is quite a good tip actually. Where do you get the equipment from? So at university, we have a very good platform where you can, so for example, for my dissertation, we have a certain budget that we can use to buy the components related to our dissertation. For my one in particular, I didn't buy the robotic arm and the cameras, and it was part of the robotics lab. So basically, they just lend me the equipment, and we are free to use them as long as we don't break it. Where do you get the equipment from? Yeah. What has been the most challenging thing you have ever done? I think moving to the UK, because I was really excited and I really wanted to do it, obviously, but it was really something new for me, and getting to a new environment, getting to new country, new language. Oh my goodness, I remember the first time I arrived here, I couldn't understand a word. I was just laughing and saying like ha 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 and I don't understand. It was like it was so embarrassing, but that's part of the learning process. So really I started from scratch learning English. It was a very challenging thing, really. Where is it? If you could work with someone in engineering, who would it be? Oh, this is nice. This is a difficult question. I think it would be, if it was possible, I would love to meet the NASA's engineers and mathematicians that I mentioned before. It was those three women were great, absolutely, and they are amazing. And I think, yeah, I think, yeah. Is it hard to build a robot? It's challenging. It's not hard. It's challenging, and you got to learn a few things. And but once you understand the basics, it's kind of you kind of know what you have to do. But then every time you have to go up to go on internet and look for data sheets and for the components, because every time there is a new component that you can use, and new processes and new programming language, for example, and things like that. Is it's just a lot of learning, really. Yeah, a lot of learning. How old were you when you first started building robots? I was old. It was just a few years ago, really. So I've never built a robot when I was younger, like when I was a child. No. What has been your favorite creation so far? So yeah, was the maze robot. That was the best one. Yeah, toughest one as well. How many robots have you made? Well, basically all the ones that I've shown you. Yeah. Why do you think some subjects have attracted males more than females over the years? I think it's not that they have attracted more boys than girls, more men than women. It's just that what I feel is that sometimes, so basically I'm also working as STEM facilitator, as there's a scheme at university called Boxed, where we as a team we go into schools and we promote science and technologies subjects, as well as other subjects as well, actually, but with the box, and we do activities with children and students in general. So I think what I noticed actually working with students younger than me, is that girls are less confident sometimes, and they get a bit like put off sometimes, saying, oh, that's too hard for me, or I'm not good enough. This is actually the worst thing. I'm not good enough. Never think this. Absolutely, you are absolutely good enough to do anything you want. Sometimes when I meet new people and like groups of people, at least one person, one girl, always, like when I introduce myself and like I'm a student engineering, etc., etc., they're like, oh, engineering, you must be smart. And I'm like, no, it doesn't mean that you study engineering you're smart. It's just a passion. It's something that you learn. And also they go like, I also thought about engineering and I would love to do engineering, but I was a bit like, that's a male thing, that's a guy's environment. So this is something that a lot of girls, I think it's something that should be promoted, really, and it doesn't have to be this way. Do you have any future designs of robots? So I think, well, my dissertation is not a full robot, but it could actually, so at the moment it will, the plan is to use a robotic arm separate and a camera separate, and they like both work together to complete the task. But then the final, the goal, the idea at the end is to be able to transfer this system into a single like humanoid robot, able to assist people, for example, with the disabilities, or elderly people in their homes as part of the assisting living environment. How many robots have you made? We need to go. Oh, I think it was a while ago, but bye. How do you make a robot move? So you program the functions for the motors. So the motors, or any kind of actuator it has, you just send it a program that says, for example, a motor run this way or run the other way, or do this or do that. So basically it's all about like motors to make the robot moving, really. How do you come up with your ideas? I just I try to think about what is what is a problem, for example, in a society, or what is something that we need, or how things could be improved, how things could be better, and that's then based on that you kind of starting getting ideas, and you read a lot, and you watch a lot of news and things like that. So you based on that you kind of get your ideas. Uh-huh. Which robots have you designed which help people to do things? So my idea was to, for the dissertation, was to design a robot that would help people to empty the shopping basket. Basically, they get a delivery, or they get something from the from outside, and like in a box or whatever, a carrier, something, and then the elderly person, for example, could not sort the shopping in the right places, or he cannot do certain things, and then the robot will help him or her doing whatever they need, and where to put things. Do you give your robots names? Yeah, we sometimes we do. Sometimes they actually already have names. For example, my robotic arm, the robotic arm that I'm using, it's called Jaco, and it's because the company who made it called it Jaco. It's the name of the model. And Pepper is Pepper because they called it Pepper, the company that made it. So it depends whether you actually build it or not. For example, the robot we've designed for the maze solving project, we called it it was a raton. It's from Spanish. It means mouse. It's because it was taken from the fact that the whole project was like meant to be in the Micromice competition, which is like a worldwide competition, and yeah, that's why. How do you feel when something fails? So to be fully honest, the first thing that I think when it fails is, damn, why it's not doing what it's supposed to do? And obviously I get upset, but then you really start thinking what it could go wrong, and what you have to do to fix it, and where the problem is, and things like that. So you kind of get distracted with the actual problem, and instead of staying always there and like, I'm a failure, I'm a loser, or whatever. No, don't think that, okay? Don't. What else? I'm reading, and most of the questions are actually repeating. So Space Studio had to leave. Bye. Sorry, I didn't see that on time. Tower School as well. Bye. When people said that you can't do something, do you ever feel like giving up? Well, it depends. It depends on the person. It depends on the way they say it, and depends on many things actually. Because I met people that the way they were saying something, like you can't do it, or you should actually just give up, or things like that. I was the first thing, because it's my character, my personality is like saying, I'm gonna show you, I will do it, I don't care, and things like that. So it depends on the person. If it's a person close to me and it says something like, you can't do it, and it says it in a way that they actually mean it, that's sad. Yeah, especially when I was younger, I was little, and I was actually starting building up my personality, and the first time, for example, my maths teacher, I really felt bad, especially because in some way I was looking up to her, and when she said that, I was, seriously? That's so sad. But then you see the evidence, you see the fact that you actually are capable, and you can do things. And if they don't like it, or if they don't agree with you, it doesn't matter. I mean, you should actually be open to other people's opinion, right? In a constructive way, in the sense, in a positive way. Accept advice, not saying that whatever the other says, you are just throwing everything in the bin. No, you listen, and then you start filtering whether it's something that you can accept or not, whether it's something it could be applied to yourself or not. And yeah, that's the main thing. We use Kapla code bugs and Lego we do at school. Have you used any of these? I haven't, but I believe one of these ones is also the same. It has also the same structure as the Lego Mindstorm, I think. It's and that's some of the parts where the parts that we use to build the line following robot. So yeah. Were the rest of your family good in technology? A little bit. Some yes, some no. It's not something related to the family. I mean, the family should be always there to support you and to push you and to get you up when you fall, right? But the fact that they are or not into technology doesn't matter. Can you interact with robots? Of course you can. Yes, Pepper actually talks. If you say like, "How are you?" things like, and you ask her any question. Well, not any question. The question that it's programmed to answer, it will answer. Yeah. It's like if you say, "How are you?" it will say, "I'm fine, thank you. How are you?" And it's like a chat robot, really. What do you do with the robots, with your robots when you have made them? Well, some, because they were like just part of a coursework at university for a module or something. Some of them, they get destroyed. Some others, they are kept by the department, and some others, they get back to where they come from. For example, the robotic arm is not mine, so I just leave it in the lab, and that's where it lives, actually. If you weren't a scientist, what would you be? This is a good one. I don't know. I think I would be. I don't know. I've never thought about it, really. I don't know, really. I don't know. What project are you working on just now? So now is my dissertation one, and we are about to start the Philippa's design as well. Have you had much help from people with your projects? Yes, a lot. Especially, obviously, group projects. We work together in most of the steps. So in some projects, you kind of split the work, but then even if you're in your own like part of the project, you get advices from the others, and you work together with the others, and you're like, oh, I can't do this, what do you think I should do? And yeah, help from the others is really key. Yeah, teamwork is the key. What route did you take into engineering? It was robotics. Yeah, it was yeah. What barriers did you face during your studies and career? Have you ever wanted to give up and do something else? No, give up and do something else. No. You could take a break, so like just to refresh your mind. And so when I moved to the UK, I took a break just like to learn the language and get used to settle and get used to the new environment. And that's also something that you could do. But then I couldn't stay away from studying and working in engineering, and so I really got back. Are you put under pressure when you are completing a project? Yes, because you've got a deadline, and there's quite a lot of pressure for the project, but not that kind of crazy pressure that, because if you know, obviously you have a deadline, right? And the first thing that they teach us to do is to plan your project. So the project plan is a big part of your project. It doesn't require to build anything. It doesn't require to code anything. It's literally just thinking, how am I going to do this before the deadline? How am I going to split my workload in a good manner? How am I going to reach the goal without getting crazy, basically? And yeah, that takes a lot of pressure away. Yeah. Have you been on I'm an Engineer, Get Me Out of Here? No, I haven't. This question comes up a lot. If you were not an engineer, what other careers would you be interested in? I don't know. I'm quite a creative person. I like drawing as well, like as a hobby. I like calligraphy things in both English and Arabic as well. I don't know. Might be that. I also like this kind of interaction with when like this part of the job where I go into schools and I support STEM subjects with children. So and also these kind of activities where I get to talk to you guys, and maybe this could be, I don't know, kind of a career, or I don't know.
Oh, Sammy, Miriam, the question again, a bit obviously because it's taking time to answer the questions, they do seem to repeat quite a lot.
Yeah.
And we are getting quite late into we've got 10 minutes over. I can't remember anyone going 10 minutes over before. Fabulous.
Okay, no,
That's wonderful.
Great.
So, and if you don't mind, if you want to carry on, please do. We've got 4 schools left. It's entirely up to you, but I'm just conscious of your time and everybody else's time.
I was thinking maybe, yeah.
It's three left now. So
okay, I think if it's because I see actually the question are always like almost repeating.
Yeah.
And yeah, we can wrap it up maybe.
Okay. Yeah, I guess because most are good. So well, thank you. It's fantastic, and I've been reading some of the comments. The people, the schools have left, and most of them say how inspiring you've been for them.
That's great.
Which is wonderful. It's brilliant.
Amazing.
So thank you very much, and thank you, Maya Park and Lingley House and Plashett. I hope you don't mind we us closing early, but well, not closing early. It is time to go. We're well over time, and thank you all very much. And
Thank you.
I will email you shortly. That's okay, Miriam. But,
Yeah.
Brilliant. Great. Thank you.
Thank you. Bye. Take
Bye,
care.
everybody.
Bye.
Actually, Miriam,
Yeah.
to close the meeting, I forgot to tell you, if you put your cursor to the bottom of the screen, you'll see end meeting.
Oh, and meeting. Yeah.
Yeah.
Thank you so much. See ya.
Thank you. Bye-bye.
Bye.